Arithmetic or linear sequences, how many terms are positive or negative? And we'll use inequalities to work these out. How many terms are positive in the sequence 27, 25, 23, 21, ... Okay, so the first thing that we have to do is realize that the word positive means greater than 0. Okay, so in order to do this, we have to first of all find the nth term. And in order to find the nth term of an arithmetic or a linear sequence, we start off by finding the difference between each term. So to get from 27 to 25, it's minus 2. From 25 to 23, minus 2. 23 to 21, minus 2. So our nth term is minus 2n. That's the first part of it. And then since 27 is the first term, you have to go back one step and find what would be term 0, the 0 term. So if we're going down by 2 each time, if we're minusing 2 each time, we need to add on 2 to find term 0. And if we add on 2 to 27, we get 29. So term 0 is 29, it's positive. So we stick on plus 29. And our nth term for this sequence is minus 2n plus 29. So since we're trying to figure out how many terms are positive, and positive means greater than 0, we take our nth term and we make it greater than 0 using our inequality signs. So we now have minus 2n plus 29 greater than 0. And we think of our greater than and less than signs, or inequality signs, as crocodile teeth, and the crocodile is always going to eat the bigger amount. So minus 2n plus 29 is greater than 0. If we were trying to say it was negative, which would be less than 0, it would be facing the other direction. But in this case it's positive, greater than 0. So now that we've set up our inequality, all we have to do is solve for n. So try and get the n on its own. And when we're solving, we always get rid of the single number first. That means the number that's not stuck onto the letters. So the minus 2 is stuck onto the n, so we leave that alone. And we get rid of the plus 29 first. So when we're solving, we always do the opposite. So the opposite of plus 29 is minus 29. So if I'm minus 29, I can cancel that out. But if I'm minus 29 to the left of the inequality sign, I must minus 29 to the right of the inequality sign. I must always balance the equation. So now I have minus 2n is greater than minus 29. Now I need to get rid of this minus 2. Since the minus 2 is stuck onto the n, and two things stuck together in maths mean multiply, and the opposite of multiply is divide, we have to divide by minus 2 so that we can get rid of that minus 2. If I divide by minus 2 on the left of the inequality sign, I must divide by minus 2 on the right of the inequality sign, because I must always balance the equation. So I'm left with n on the left hand side. The rule with inequalities is if you multiply or divide by a negative number, you flip the inequality sign the other way. So it changes direction. So we've now got n as less than, and minus 29 divided by minus 2 is going to be plus 14.5, or just 14.5. Now, what does this mean in words? This means n is less than 14.5. Now, n has to be a whole number. N has to be a positive whole number, a natural number, because there is no such thing as saying 14.5 terms in a sequence. There's 14 terms in a sequence, or there's 15 terms in a sequence, or there's 16 terms in a sequence, or 100 terms in a sequence. But there's no such thing as 14.5 terms. So the actual answer to this is n equals 14. There are 14 terms in this sequence that are positive. So now we want to find out how many terms are negative in the sequence minus 82, minus 79, minus 76, minus 73, dot, dot, dot. Well, the first thing we have to realise is that negative really means less than 0. So we're going to work it the same way we did the last one. We're going to find the nth term and let it be less than 0 using inequality signs. So to find the nth term of an arithmetic or linear sequence, we start off by finding the common difference between each term. And to get from minus 2 to minus 79, it's going to be plus 3. From minus 79 to minus 76, plus 3. And from minus 76 to minus 3, plus 3. So our nth term is 3 with an n stuck on, that's the first part. And now we have to find the 0 term. So since minus 82 is the first term of our sequence, we need to go back one step and find what would be the 0 term. So since we're adding on 3 each time, now we need to minus 3 to get to our 0 term. So minus 82 minus 3 leaves us at minus 85. So minus 85 is our 0 term. So we stick on minus 85. And now we have the nth term of this sequence. So now we need to make this less than 0 and again solve to get the n on its own. So we have the nth term, 3n minus 85 is less than 0. So again, we are going to balance out the equation, getting rid of the single number first. So we want to get rid of the minus 85 first. The opposite of minus 85 is plus 85. If I plus 85 to the left of the inequality sign, I plus 85 to the right. I must always balance the equation. So I can cancel that out. So I'm left with 3n less than 85. Now I need to get the n on its own, and the n is stuck onto a 3, and two things stuck together in maths mean multiply, and the opposite of multiply is divide, so I'm going to divide by 3 on both sides. And I have n is less than 28.333, so basically 28.3 recurring. I do not need to flip the inequality sign as I did in the last example, because I've divided by a positive number here. In the last example I divided by a negative number and then the inequality sign flipped, but we don't need to do that with this one. Now what does this mean in words? This means n is less than 28.3 recurring. Now n has to be a positive whole number because there's no such thing as 28.333 terms. That doesn't make any sense mathematically. It's like you can have 28 people or 29 people or 30 people. You can have 28 terms or 29 terms or 30 terms. You can't have 28.333 terms. So we need to find the whole number, the first whole number that's less than 28.3, and that is 28. So n equals 28. So there are 28 terms in the sequence that are negative. How many terms are greater than 50 in the sequence 76, 72, 68, 64, dot, dot, dot? Okay, so again, we're going to start off by finding the nth term of this arithmetic or linear sequence. And we start by finding the common difference between each term. To get from 76 to 72, it's minus 4. 72 to 68, minus 4. 68 to 64, minus 4. So our nth term is minus 4n, and then we need to go back and find the 0 term. So if we're minusing 4 each time, we now need to add on 4, and 76 plus 4 gives us 80. So 80 is our 0 term, it's positive 80, so we stick on plus 80. So the nth term of this sequence is minus 4n plus 80. And now we need to make this greater than 50 and solve to get the n on its own to find how many terms are greater than 50. So we have minus 4n plus 80 is greater than 50. Again, the alligator will always eat the bigger amount. So if minus 4n plus 80 is greater than 50, the alligator teeth have to be pointing towards that. So now we need to solve to get the n on its own, and when we solve, we always get rid of the single number first. So the opposite of plus 80 is minus 80. I'm minus 80 to the left of the inequality sign, and I'm minus 80 to the right of the inequality sign because I need to always balance the equation. That gets rid of that. And I have minus 4n is greater than minus 30. Now I need to get rid of the minus 4, and it's stuck onto the n. Two things stuck together in maths mean multiply, and the opposite of multiply is divide. So I divide by minus 4 on the left of the inequality sign, and divide by minus 4 on the right of the inequality sign. That leaves me with n, and I need to flip my inequality sign the other way around because I've divided by a negative number. If I multiply or divide by a negative number, I flip the inequality sign. And minus 30 divided by minus 4 is 7.5. So what does this mean in words? This means n is less than 7.5. And again, we have to have a positive whole number as our answer because there's no such thing as 7.5 terms. So the closest whole number that is less than 7.5 is 7. So n must be equal to 7. So there are 7 terms in this sequence that are greater than 50.